Welcome to another magnificent conversation. Today's conversation, the special guest is the special right triangle 345. Now, the 345 special right triangle is something that's important if you want to save time on exams like the SAT or an AP Calculus or an AP Pre-Calculus exam. So it's not one of those things where it's necessary to know, but if you know it, you will save a lot of time. So let's first go through the 345 triangle. So if a triangle is a 345, the legs are length 3 or 4. The hypotenuse is always 5. And we should know that because the hypotenuse should always be the longest side, because for a right triangle, it's always going to be across from the largest angle. So if we're looking at our triangles over here, we know the hypotenuse is 5, the shorter leg is 3, and the longer leg is 4. Same here, hypotenuse is 5, longer leg is 4, shorter leg is 3. What this means is if you know 2 of the sides and you know the hypotenuse is 5, so it's always important to know in those sides that I know is the hypotenuse, the long one, and is 3 and 4, one of the legs. Then you don't have to use the Pythagorean theorem. You automatically know which one is missing. So let's look at a couple problems that'll help you quickly solve problems and save you time when you're testing. Let's say we're given the right triangle that's drawn, and we know given tangent of theta is equal to 3 over 4, calculate cosine of theta. So we're going to break down what information is given to us. We have our right triangle, so we know where our theta is. So I'm going to label my sides based on my theta. If this is my theta, we know this is opposite. If this is my theta, adjacent is next to, and hypotenuse is always across from 90. I also know tangent of theta, which we know is 3 over 4, is opposite over adjacent. That means my opposite side is 3 units long. My adjacent side is 4 units long. Because my legs are 3 and 4, my hypotenuse is automatically 5. And I can go ahead and say cosine of theta, which is adjacent over hypotenuse, is 4 over 5. All right, let's look at another example. We have our right triangle drawn. Given cosine of theta is equal to 3 over 5, calculate sine of theta. Okay, our theta is drawn, so we're going to label our sides. If this is theta, this is opposite, adjacent is next to, hypotenuse is always across from 90. We know cosine of theta is equal to adjacent over hypotenuse, which is 3 over 5. So that means my adjacent side is 3 and my hypotenuse is 5. All right, we've got 2 sides of our triangle. The hypotenuse is 5. One of the legs is 3. I automatically know the other leg is 4. So I go back, sine of theta, which is opposite over hypotenuse, is 4 over 5. All right, our right triangle is drawn. Given cosecant of theta is equal to 5 over 4, calculate cotangent theta plus secant theta. Okay, so we're going to start this the same. Get our sides labeled. If this is theta, this is opposite. Next to is adjacent. Across from 90 is always hypotenuse. So we know cosecant of theta is hypotenuse over opposite. And it's equal to 5/4. Okay, so my hypotenuse is 5. My opposite side is 4. Here we go. I have two sides of a right triangle. The hypotenuse is 5. One of the legs is 4. The other leg is automatically 3. So what I want to calculate is cotangent of theta plus secant theta. Cotangent theta is equal to adjacent over opposite plus secant theta is equal to hypotenuse over adjacent. So adjacent side is 3, opposite side is 4, plus hypotenuse is 5, adjacent side is 3. I have two fractions that I need to add. I'm going to crisscross and across these. So multiply, multiply, multiply. So I end up with 3 times 3 plus 5 times 4 all over 4 times 3, which is 9 plus 20 over 12, which is 29 over 12. You definitely want to know how to simplify fractions because on testing, even if your teacher doesn't require you to simplify, multiple choice questions will have simplified answers, not unsimplified answers.
Why do you call a seagull a seagull?
Why?
Because if they flew over the bay, they'd be called bagels.
Okay, we've got our right triangle drawn, and we are asked to calculate tangent of theta. So I initially look at my right triangle, and I do like I always do. I label my sides: opposite, adjacent, hypotenuse. So tangent is opposite over adjacent. So I have my adjacent side, but I need my opposite side. I'm looking at my triangle, and this is when you get really, really good at your 3, 4, 5s, and you're really, really good at your multiplication facts. I see my hypotenuse is a multiple of 5. It's 5 times 5. And I see one of my legs is a multiple of 4. It's 4 times 5. Okay, so that means I'm still dealing with a similar triangle of a 3, 4, 5, which is great because that means I don't have to go through the Pythagorean theorem. These numbers are big. The Pythagorean theorem would be very cumbersome. So that means if my hypotenuse is a multiple of 5 and one of my legs is a multiple of 4, that means my other leg is a multiple of 3. So if you see, it's still a 3, 4, 5, but all of my legs are multiplied by 5. So that means my opposite side is 15. And then I go back, tangent of theta is equal to 15 over 20, which is 3/4. Now, you don't have to do it this way. If you wanted to go through the Pythagorean theorem to find the other leg, you're going to get to the same answer. Just remember, I'm teaching you ways to save time on standardized testing. Okay, we've got our new triangle. It's labeled. This question wants you to calculate tangent squared theta plus secant squared theta. Now let's go back to our triangle, get our sides labeled so we know what information we have and what we need. This is my theta, this is my opposite. Next to is my adjacent. Across from 90 is always my hypotenuse. Okay. I look at my triangle, and again, do I see what I see? I know 9 is a multiple of 3. It's 3 times 3. So if my other leg is 4 times 3, then I know I'm a 3, 4, 5. Well, 12 is definitely 4 times 3. So this is a similar triangle to a 3, 4, 5 where all the sides are multiplied by 3, which means my hypotenuse is going to be 5 times 3, which is 15. Okay, so let's go back. We have all our sides. That means we're good to calculate tangent squared theta plus secant squared theta. One thing I like to do is rewrite my trig function squared when I'm evaluating like this. So I know I find tangent theta and then I find secant theta and then that's what I square. So we know tangent of theta is opposite over adjacent and secant theta is hypotenuse over adjacent. Okay, my opposite side is 12. My adjacent side is 9. My hypotenuse is 15, and my adjacent side again is 9. Now, when you get better finesse with math, you know to simplify the fraction before you square it, because smaller numbers are easier to work with. So 12 over 9, both are divisible by 3, simplifies to 4 over 3. 15 over 9, both are divisible by 3, simplifies to 5 over 3. The square fraction means we square both the numerator and the denominator. So this is 16 over 9 plus 25 over 9, which is 41 over 9, which cannot be simplified any further. Let's look at our last example with our special guest 3, 4, 5. Okay. We have our right triangle drawn. Given cotangent of theta is equal to 3 over 4. Calculate 5 sine theta minus 3 tangent theta. Okay, let's get our triangle labeled and then figure out what information we were given. If this is theta, we know this is our opposite. Next to it is the adjacent, and across from 90 is always the hypotenuse. And so right now, all we know is the hypotenuse of our right triangle is 20. We were given that cotangent of theta is a ratio of 3 over 4. Now remember, when we have our trigonometric ratios, that number can be a simplified version of what the triangle actually was. So you have to make sure it makes sense. Cotangent is adjacent over opposite, which we know are both of our legs. So if both of our legs are 3 or 4, we know the hypotenuse is 5. Right now our hypotenuse is 20. So that means all of our legs are multiplied by 4 because 20 is 4 times 5. And we know it has to be a multiple of 5 because the legs simplify down to 3 and 4. So that means our adjacent side is 3 times 4, which is 12. And our opposite side is 4 times 4, which is 16. So now we're able to label all the sides of our triangle and we can answer our question. So 5 sine theta minus 3 tangent theta. We know sine of theta is opposite over hypotenuse. Tangent is opposite over adjacent. So here we have 5 times 16 over 20 minus 3 times 16 over 12. This is where you need a little bit of finesse when it comes to simplifying. So 5 and 20 are both divisible by 5. So 5 simplifies to 1 and 20 simplifies to 4. So here we have 16 over 4. 3 and 12 are both divisible by 3. So 3 simplifies to 1 and 12 simplifies to 4. So this is again 16 over 4. 16 over 4 minus 16 over 4 is equal to 0.